أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Welcome back again to another new lecture. This is week 4 lecture, where basically we will continue from the last lecture that what we have learned. Today's topic is we will cover all the coordinate systems related to rectangular, cylindrical and spherical coordinate system. We will learn all aspects about them, and also we will learn about how to transform among the coordinate system. At the end we will do some examples to clear how actually we will transform from one to another, and so on and so forth. So without any delay, let's go to the contents. Basically we have 3 different coordinate systems in day by day use, or like, you know, whenever we find some very algebraic, you know, way of representing any points or any any values, we usually use this rectangular coordinates. But apart that, there are 2 more different coordinate systems also, which is cylindrical coordinate system, and also we call it spherical coordinate systems. So there are basically 3 different coordinate systems. So rectangular coordinate systems, cylindrical coordinate systems, and the spherical coordinate system. This all we know actually. So whenever we use any of like 2D coordinate system, we go for x axis and y axis. So we go x and then y, and then we find the point, right? But if we add one more additional axis, let's say we have x, which represent this one, y, which representing this one, and the z. Think about the corner of any room. A room have a corner like this, right? So the height of the room will be the z, the length will be x, and the width will be y. So here it's a 3D cube actually, where we can project any points in anywhere. So first what we do is we go x, which is this value, and then we go y, and then at the end we will go z value. So, and then after that we will finalize and find our point here. So how we represent this one is the point P, which x, y and z coordinates, means we go x first, then we go y, and then z. So by doing so we will find the value of, actually the point of P. So this is basically very normal system of coordinate, which is we call rectangular coordinate system. Sometimes we call it Cartesian also. So if we call it Cartesian or rectangular, they are the same actually. So we move on. This is we know already, so but I'm just giving you you know, a juggle in the memory, that's all. Remember one thing, the limits of all the you know, values of the coordinates are very important. So in the rectangular coordinate system, basically we have x, y and z, which can go plus and minus. So any value in the minus domain or in the positive domain, means minus infinity to plus infinity. It means it can be any value. Similarly, y and z also have the same criteria. X, y, z, they can have any value in between minus infinity to plus infinity, means any value. Plus 1, minus 1, 0.5, 0.112, any values. And of course, to represent this one, we will need all the unit values in the direction. This is ax, ay, and az, means this one unit value, sorry, unit vector in x direction, this is a unit vector in y direction, and this is a unit vector in z. Later on we will see more applications of this one, but we move on now to cylindrical coordinates. Unlike, let's say, this point here, right, we will find this point here, right, by going x, y, and then z, right? But now let's say this point, we will not go like this. We will try to go in a cylindrical way. How? This much we will go first, and then we will try to create an angle, and then we will go z. So this and this angle will replace the x and then y, but we will keep the z. Means this x, y, and z is no longer anymore, but we will represent, instead of x, we will say that we will represent in rho, phi, and z. And then rho signifies actually basically any distance from anywhere. Actually, from here it can be, from here it can be, from this plane can be, from here, but it have to be in this plane. Means let's move to the next slide, and then you will understand better from here. Okay, so this is xy, z means Cartesian coordinate, right? That we learned already about it. So x and y, right? We keep this xy, x, this is y and z axis. Try to represent the same point in cylindrical coordinate system. How? So we declare one, that we have a distance here. Let's say we have a distance here, rho, and then that distance have an angle with an x axis is phi. So from we get this one first, and then this much rho values we bring like this to a rho distance, which is phi angle. So the rho distance, if we move phi angle, then we come here, and then we just need that z distance to add up with this to locate this point. This is simpler actually, so there is nothing complex about it. It's just a representation in a different way, that's all. But the point, the values, even the values are different, but the point is the same. However, this rho value, rho have its own value actually, which is from xy we can derive. Now see, the similarity between them is z is the same, so we don't concern about z, we concern about this rho and phi. So these are the equations here, rho and phi. But we need to know actually that how this comes, how we get this one. So we move on to the next slides to learn actually how we get these values. Rho is equal to root over x squared plus y squared, x equal to rho cosine of phi, and so on and so forth. We need to go to a very, very basic thing, which is called Pythagoras theorem. So Pythagoras theorem, actually we know that if there is a right angle triangle, then rho square is equal to x square plus y square. So rho square is equal to x square plus y square, and then when we square root this one, so we got rho is equal to x square plus y square square root. So this is done, this is we know. From here, this there is, if this is the angle we are defining, we can define angle here also, but based on the trigonometric principle, which is also Pythagorean principle, we can actually find these values here. How? We know what is sine, right? Sine of phi is equal to this divided by this, which is opposite divided by hypotenuse. So y divided by rho. So we multiply with this one, so we get y equal to rho sine phi. So we get this one. Similarly, we get this one from the cos theta. Actually cos phi here, because this angle is phi, which is cos phi is equal to adjacent divided by hypotenuse. This is adjacent, right? Because adjacent means with this angle. So this is adjacent and this is hypotenuse. So x by x over rho. So we get x is equal to rho cos phi. As simple as that. And this one we get what? 10. 10 phi is equal to y by x. Similarly, opposite by adjacent. And phi is equal to 10 inverse y divided by x. So this is how we get these values, as simple as that. However, these things are very important. We usually ignore this type of values usually. So you have to remember one thing, that rho value, the value of rho, this one, value of rho here, it cannot be negative. So the rho value cannot be negative. Remember this one. And the phi value, and the phi value can be anywhere. So 360 twice pi means 360, right? And the z value, as we knew already here, z is unchanged. So the z here is unchanged, so it can be any plus or minus values. So that's how we got the cylindrical coordinates. Now we move on to the spherical coordinates. Similar way, same point, like the Cartesian and the cylindrical coordinate, we will represent this one to one more different way, which is called spherical coordinate system. There is one small similarity actually. We will say that there is phi will keep only, but we will not take rho anymore. We will take r value, the distance directly from the origin to the point. So this is r, and then we declare one angle, how far it is from z axis, and then this r, how far it is from the y axis. So we only declare that r, phi and theta. It somehow, if we go to the next slides, it looks like this. So first we declare this r, so this is r value, and then how far is this one, and then how much we're gonna rotate. So we declare r first, and then in what plane we will rotate like this, so theta, and then we will rotate into phi. Or we can do like this, that we first declare r, and then we find this r and which plane this r is, and then we rotate into theta. So there are two different angles here. So in similar way, actually I will not describe more how we got it, but because I already have explained you here a little bit. So if you want to understand more how you get it, so we need to research a little bit. This one, it's up to you. Based on these two angles, actually, based on two triangles, the conversion has been done. So x equal to, we know that rho cos theta, so the rho value again r sin theta, so we replaced here, and we know that z is we know here rho, somewhere here rho will be there, so rho is square and z square. If you look here, r square is equal to z square and rho square, right? R square here is equal to z square plus rho square, but rho square means we know that x square plus y square. So that's how actually it happened. I will not go so deep into it. Rather, we will take it and we will use it how to transform different values of in between different coordinate systems. One more points here to remember, this one, that R value cannot be negative. You have to remember, if there is R value negative, in some point it comes R is equal to negative, then your calculation is not valid. It means there must be some mistake that you already have done. So, and theta, the theta value, it cannot be more than pi, means 180 degree. So it cannot be more than pi values. And phi, as usual, that what we have taken it from the spherical cylindrical coordinate is the same. So 0, in between 0 and twice pi, anywhere. So 360, it can rotate 360. This only can rotate 90 degree, and this R cannot be a negative value. So that's how we actually represent. It's a summary, kind of summary a little bit. So the coordinate representation, the same points, P is equal to X, Y, and Z. Cylindrical, in rectangular, we do X, Y, and Z. We represent it like this. In cylindrical, I done again one mistake. It's supposed to be spherical. Supposed to be spherical. So the spherical, in the spherical, PH, spherical, okay. So in spherical, in cylindrical, we have rho, phi, and Z, and in spherical we have R, phi, and theta. This is the representation so far. We know already now. And the pointing vectors, how we gonna write it down is, we know about this already. This can be I, Z, and K, I, J, and K, or AX, AY, and AZ. In similar way, it can be in the cylindrical, it can be rho, phi, and Z, and for a spherical it will be AR, A theta, and A phi, or vice versa. It can be A phi or a theta, no problem. It can be either this, it doesn't matter actually. So there will be a component on each directions. You have to remember this one. So if you have a cylindrical, rho direction component, phi direction component, Z direction component. If you have a spherical, then it's R direction component, theta direction component, and phi direction component. There are some few important points we have to address also. Before we address some important point, this is also the way that we do the vector magnitudes we find. So if we find the modulus of any coordinate system, it's the same. X square, Y square, Z square, rho square, A phi square, A Z square is same. So I will not go so deep and far into it. So this is something that you should know whenever you see any coordinate representation or given to you. If you find out that there is all lengths, means all are values actually, means there is no angle involved, that should be and will be and must be a rectangular coordinate system. For cylindrical coordinate system, remember this one, two coordinates are lengths, means values, okay, means 2 and 3, rho and Z, but there will be one angle, anywhere they put. So this will be one angle. And spherical, there must be two angles here. So this is a clear distinguish between how to find out from open eyes, without knowing much deep inside it. Once you see any coordinate given, you can directly define and identify which coordinate system it belongs. If all three are only values and lengths, then it's from the rectangular coordinate system. If there is only one angle and two coordinate are lengths, means you find one angle first. If there only one angle, then it must be cylindrical, and if it's a two angles, then it's have to be the spherical coordinate system. So that's how actually you will identify. It's like a very quick way to identify the vector definitions of the different coordinate system where they belong. Now we move into the transformations of different coordinate system in between, from rectangular to cylindrical, or from spherical to rectangular, and so on and so forth. Here first we start with rectangular to cylindrical, where we have x, y and z values. Then we will transform it to rho, phi and z. I put so many transformation ways to do it, the derivation. I don't want you to go through that much, but I just put it. If you become curious and then you want to learn about it, you just go through it. I will not go through so deep inside. No need actually. But if you want, you can go. You have the freedom to do it. But rather, we will go directly to the point where we can actually transform this one. So we want to find out the cylindrical from the rectangular, right? So rectangular is given, we need to find the cylindrical. So we need to multiply with this. What is AX? AX is the value of any formation. We know already about it, so I will not discuss so much about what is X. Later on, actually, we will find out when we do our examples. But as far as I know, last year also and the year before also, formulas will be given. So don't worry about it that you have to memorize these formulas. No need to memorize the formulas. However, from here you can, with using this equation, you can directly convert the rectangular coordinate system or Cartesian coordinate system to cylindrical coordinate system. How? So if you want to find this one, then you have to multiply this whole thing with this. How? So this multiplies with this multiply with this, and this multiply with this is equal to actually this one. So this multiply with this plus this multiply with this plus this multiply with this is equal to this one. Similarly, if you want to get this one, so this whole thing multiplies with this row. So this multiply with this plus this multiply with this, and similarly this multiplied plus this multiplied with this. And similar way, if you want to find out this one, so the whole thing multiplies and then added. Now if you want to move into like rectangle, now we convert it to rectangular to cylindrical, right? Now if you want to do cylindrical to rectangular, you need to do, it was here like that, right? So you need to bring this one here, right? So we do, what we do is this one, what is we call it the inverted matrix or matrix inversion. So I would like you to explore more on the matrix inversion. If you feel difficulty, possibly maybe I will update one extra video, helping video, how to do matrix inverse. That maybe it will be helpful for you. So once we do this inversion, we get something like this, and then by the same way if we have a cylindrical coordinate system rho, phi and z, we can find out a, y and z also. Now we move on to one more thing actually, to say that if if let's say if you want to find out x, y and z, right? So you cannot have any phi or any phi rho element, right? Since when you convert, so here look at here, this, so these phi's are needed to be replaced actually. So but we know that phi is equal to cos phi and sin phi is equal to x divided by rho and y divided by rho respectively. So x is there, but rho we replace here and we get this one. So remember one thing, when we do example we will learn more about it, that if it's a rectangular coordinate system, then there is no theta or phi or rho can stay there. So everything needed to be converted into x, y and z. That's why the resulting transformation system is having x, y and z. There is no z here, somehow it can come if there is only any z element here. So that's how you have to remember, but when we do one example it will be more clear for you. So to go for rectangular to spherical coordinate system also is quite similar. I put some calculations here, but it's up to you if you want to learn about it. I will not describe this one, rather we will take the solution and we will use it, how to apply. So it comes like this. It's quite long equation. By the way, remember this one, this type of solutions are actually quite long and tedious and boring. However, well, to learn about the electromagnetics, you need to learn about these transformations. So here, if rectangular coordinate systems is given, then we will find that we by this equation we can find out the spherical coordinate system. How we know it's spherical? Because this is r, theta and phi. There are two angles here involved. And the similar way, if we want to find AR, so we multiply AX with this plus AY with this and AZ with this. And similarly, we find A theta and A phi by using the same matrix multiplication way. However, in a similar fashion, if we try to find spherical, from spherical to rectangular, we just need to, as you find it here, so we need to bring it this side. If we bring this side, so it becomes metric inverted. So inversion, metric inversion you need to do. So if we do this 3 by 3 metric inversion, it becomes somehow like this. Don't worry, I will put matrix inversion video, how to invert 3 by 3 matrix, inshallah. So by doing this one, we find out what is x, y and z by multiplying AR with A theta and A phi with these elements. And similarly, we know that if it's x, y and z, we cannot have phi, theta, r element. So by changing sin theta, sin phi, cos theta and cos phi, we need to replace this one, and then we're gonna get our rectangular coordinate system. So these all are actually, we actually covered all the systems already. So from all the conversion, how to do it, there are some summary tables here. You can check that what to do with if it's a dot product unit vectors, then how we can do it. But I would rather ask you to study this one and this one more. However, if let's say rectangular to cylindrical, you follow this. And then if it's a cylindrical to rectangular, then you follow this. Spherical to rectangular, you follow this, and so on and so forth. Once we do one example, it will be much clearer for you. And there's more summaries, with some vector components and unit vectors and how to transform. I will stop this video now. I will continue with another video. Actually, I don't want to make it too long and too boring. So in part 2 we will do some examples, and from that example we will learn how to use this formula to transform in between the different coordinate system. Jazakallah khairan. Assalamu alaikum wa rahmatullah.